The traditional data center handled the computing needs of an entire organization. People sent in work, and the center processed it. With the data center in control, data center managers knew that all the company's computer equipment was compatible and its applications were uniform. This made sense in terms of service, maintenance, and cost. But the demand for more computing power has grown dramatically over the years, and there's no end in sight. As users ask for greater speed and computer resources, they've tried to meet their needs with small departmental processors and desktop computers. As a result, control has migrated away from the data center. An endless variety of architectures and applications have proliferated in departments and branch offices, making networks both expensive and difficult to maintain, service, and coordinate. What we need is a solution that returns control to the data center, a solution that lets the data center manage a large network of distributed systems without having to add significantly to the size of the staff. The solution would have to provide end users with the speed and accuracy they require, and with access to the data center and to all other localities as well. Finally, this solution must be evolutionary. That is, it must change whenever the needs of the organization change. This videotape is about a solution we at IBM call VM Distributed Systems. VM Distributed Systems is a networking strategy. With VMIS networking software now available, you can have the benefits of distributed processing today. Our networking strategy is best understood by contrasting it with other network configurations. Let's start by considering the traditional data center, which consists of one or more large processors at a central site serving a vertical network of terminals and desktop computers. This vertical network is managed by a staff of experts who control the flow of information to and from the central site, develop application programs, monitor and control the network traffic, back up the system, and so on. Because the network is controlled by a single staff at a single site, it is consistent and manageable. What's more, some data processing applications are best kept at a central site. For example, database management and high-volume transaction processing both require the storage capacity and computing power of a large mainframe. And certain data, such as payroll files, should be kept at a central location. But there are times when applications should be run locally, independent of the central site.
How much is the tax?
For example, car dealerships need access to the automaker's mainframe system to place orders and check delivery schedules. But it is more efficient for them to have their own local processor to track sales volumes, improve customer service, and run their own business programs. Or you might have a market research team doing some computer-intensive studies, but only at certain times of the year. The processing power needed for this research might slow response time for everyone on the network and introduce new problems by altering the mainframe's environment. Instead of upgrading the mainframe computer to meet a seasonal demand, it would be more efficient to provide this research team with its own distributed processor. Then there is the manager of a large manufacturing plant who wants a distributed system for running office and decision support applications and for monitoring local inventory volumes, but who also wants access to the home office when placing orders for new inventory. In each of these examples, work groups have found it more efficient to run their applications locally, independent of a central site. As these work groups purchase their own processors, their systems can grow into another kind of computer network, what we'll call a horizontal network. In a horizontal network, processors at different locations are linked together, and each processor is managed by its own data processing staff. Each staff maintains its own data files and application programs. By running these programs locally, closer to the end user, system response time improves, and if a problem should develop with any one processor in the network, only the users connected to that processor will be affected. In this diagram, Department A runs its own unique applications on its own processor. Departments B and C do the same with their own special applications. By linking these three processors together, we can build a simple horizontal network. But there are some drawbacks to linking processors together horizontally. Notice that each department requires its own technical support staff to maintain the processor and the applications it runs. These three departments require 3 support staffs, each duplicating the work done by the staff at the central site in a vertical network. If a problem occurs when a member of Department A sends a file to a member of Department C, the problem could go unnoticed because there is no central staff managing network communication. What's more, horizontally connected departments often implement different solutions to the same problem. And someone transferring from Department A to Department C might have to learn a whole new set of applications, even if those applications do the same work as the ones used in the former department. What is needed then is a computer system that offers the advantages of both a vertical network and a horizontal network. A solution that gives a data processing staff the tools to manage and administer an entire network from a central site, but which also provides the efficiency and response time of a horizontal network. IBM's VM Distributed System strategy is that solution. By adding a middle tier of 9370 processors to your computer system, distributed processing becomes both horizontal and vertical. In a network managed with VMIS software, information can still flow horizontally from one local site to another, but it can also flow vertically between the central site and a distributed site. Likewise, the staff at the central site can reach out vertically to assist users at any distributed site in the network. Remember that in a horizontal network, every site requires its own technical support staff to support its own processor and its own applications, a duplication of effort which makes inefficient use of your personnel. With a middle tier of 9370 processors, you can manage your entire network with the skills at your central site. Your data processing staff can distribute the system support, applications, and operation skills your users need. IBM's VM Distributed System strategy offers a complete approach to centrally managing a distributed network. For example, our automated operations tools allow the console at your central site to serve as the console of any distributed site in your network. A system programmer can tailor your automated operations tools to do routine work such as backup and network management. These tools respond to most system messages and only route messages they can't handle to the central site. That way, the operator at the central site can assist and operate any system throughout your organization, regardless of how far away. By managing your distributed systems from the central site, you can also ensure the timeliness and accuracy of your information. Distributed sites can exchange data with the host computer, which keeps the data current. Your applications can be run using this current data to create the high-quality information you need to make timely business decisions. Training will also improve. Your central site can distribute uniform programs. As a result, your data processing staff will only have to teach one course, where formerly they might have taught several courses on several applications that all did the same work. And by standardizing your applications, you'll make the members of your organization more productive. A user who transfers to another department or moves to another location will recognize the same applications and can quickly return to doing productive work. In fact, your entire system can remain uniform by first testing, updating, and servicing software changes at the central site, then distributing those changes throughout your network. When it comes to planning and installing a distributed system, IBM offers the flexibility to meet the unique needs of each separate location. For example, if you're planning to install multiple 9370 systems with similar software, IBM offers the 9370 Express Software Preload service. This new service allows customers to provide IBM with a tape copy of their existing software. IBM will load this software onto each 9370 system prior to shipping. This preload service shortens installation time and reduces the need for system programmer skills at distributed sites during installation, thereby increasing the productivity of your support staff. Also, when planning your distributed system, you can choose from a range of 9370 models to meet the unique needs of each site. For example, if the location doesn't require a lot of computing power, IBM can offer a 9370 Model 20 This processor doesn't require a special raised floor or additional air conditioning. If the office is comfortable for people, the odds are it's suitable for a 9370 Model 20 as well. Other models of the 9370 product line can provide additional processing power as your distributed sites continue to grow. Or you can step up to our family of large 370 processors and build on your investment in System 370 applications, hardware, system software, and skills. These choices translate into real savings to your organization. When you need more computing power, you can still choose to upgrade your mainframe computer. But if this upgrade would deliver more power than you need, you can also choose to upgrade a 9370 to a higher model or add a new 9370 to your existing network. As we've seen, distributed systems managed with VMIS software provide both vertical and horizontal connectivity. They can be managed by the skilled personnel at your central site with software that automates many system management tasks. Because users have access to corporate files, the information they use is timely and accurate. With applications developed at the central site, your staff can train others to use a set of uniform programs. Changes and software upgrades can be distributed from the central site, and new 9370s can be preloaded with customer software before delivery. Finally, these 9370 systems can be upgraded incrementally as your need for computing power continues to grow. With the help of your IBM representative, you can design a network of distributed systems that's right for your organization. And with a network of VM distributed systems managed from your central site, you can distribute your applications and your expert skills wherever they're needed.